everyone, and welcome to my lab. I'm so happy to see you on this very special anniversary program, the 50th annual Once Upon a Christmas Cheery in the Lab of Shaka Shiri. Thank you. It's a very special event, and I'm thankful to the Science is Fun Band under the direction of Professor Mike Leckrone. I'm also thankful to PBS Wisconsin. We have had a partnership for 5 decades where they bring this program to people all around the state of Wisconsin, indeed all over PBS stations around the country. So thank you again for being part of this very special event where we will do science experiments. Together we will explore and learn and think about what you experience. In my lab, we always obey the safety rules. You notice already I have my goggles on, and I have this fire extinguisher. It's not a toy. It's part of the safety procedures that we have, and I'm going to set it right here so you and I know where it is, just in case it's needed for something that might go out of control. We're not planning on anything going out of control. We just have it as part of the safety regulations. Safety is paramount in everything that we do. And in the experiments that we're doing today, you will be, along with me, looking for color changes, explosions, liquids that glow in the dark. You just be on the lookout. So sit back and relax. And if you pay attention, you're going to learn quite a bit of science, and you're going to be having, I hope, an enjoyable experience. So, are you ready to learn? Yeah. Are you ready to have some fun? Well, let's get started then. And I'm going to turn this on, and oh, that got your attention. This is an example of what we call a controlled combustion reaction. The gas propane is burning and gives us this nice, beautiful flame. You can see the yellow color at the top, and down at the bottom, if you're close enough, you can see a blue tinge to the flame. There it is, very beautiful blue tinge that we have. And this is controlled combustion, just like the reaction of a flame in the candle. And I'm going to try to lower it down a little bit here, like so. Now, when you came in, you notice that we have a lot of equipment and material, not only on the tabletops, but we have some things up in the air. What do we have up in the air? And how many balloons are there? 6. Are they all the same color? No. Well, maybe that is a hint for me and for you to pay attention, because I'm going to tell you that these balloons, as you already know, have gases in them that are lighter than air. That's why they're up in the air. And what I'm going to do is take this flame and set off, if I can, reach it. Yes, I'll be able to reach it. I'm going to set off the flame to this balloon, and we'll see what happens. You ready for this? Yeah. Some of you are covering your ears. Why are you covering your ears? Because you know from experience that there might be a loud sound here. So here we go. Let's try it and see what happens. Well, that balloon had in it the gas helium, and helium does not burn. What we always do in science is repeat the experiment. So let's go over to the same colored balloon. I like the smile on your face. And you ready for this? Let's see what happens now. Did the same thing happen? Exactly the same thing? No. In the second balloon, the flame went out. Maybe you're thinking about, why did the flame go out? The balloon had in it the gas helium. Maybe the flame went out because I brought it too close to the balloon. You think about what you see and what you hear and try to make some sense out of it so that you can enjoy as much as possible the explorations that we go through here. Well, I have a couple of other balloons right here, and let's see what happens when I put the flame to this balloon here. You ready for this? Yes. You sure you're ready now? Yes. Here we go. did that balloon have helium in it? That balloon had in it the gas hydrogen. And hydrogen combines with oxygen from the air in what we call an uncontrolled combustion reaction. You know what's another name for uncontrolled combustion reactions? Explosions, yes. And what do we always do in science? Repeat the experiment. So let's repeat the experiment, but this time let's do it in the dark and see if we can learn some more as we bring this here. Ready for this? Here we go. Did you see that ball of fire? And did you hear a louder explosion than the popping of the helium-filled balloon? Let's have a look at this last experiment in slow motion. So watch the monitor. You see the flame coming close. You won't hear a sound right now. And there is that big ball of fire. So when we look at things in slow motion, we learn a few more facts, and we can think about what we've learned. All right, so we've got lots of experiments lined up here, but we still have 2 balloons over there. Shall I do experiments over here or do more balloons? More balloons? Okay, let's move over to more balloons. And when we do these experiments and we make sense out of them, we pay attention. You paid attention, and you noticed that the hydrogen-filled balloons gave us a louder sound than the helium-filled balloons. So maybe these will give us even a louder sound. And that's why I want everyone to protect your ears from potential damage by taking both fingers and you stick them in your ear very tightly. I cannot do that and do the experiment at the same time. That's why I have ear protection like this. Now, if you can hear the sound of my voice, that means you don't have your ears well protected. All right, I saw your smile. That means you don't have your ears well protected. Please protect your ears very well as we go now to this balloon right here. You ready for this? Another uncontrolled combustion reaction, and that is louder because the balloon had in it a mixture of hydrogen and oxygen and gave us a louder report. What do we always do in science? Repeat also the safety precautions as we go to this one and try to do it in the dark. If we have the lights down. You ready for this? Ready? Let's have a look in slow motion. Again, you won't hear the sound, but you'll see a much faster reaction because there is more oxygen on the inside. The ball of fire did not last as long. And of course, you heard, even with your ears protection, a much louder report. Well, before I go on with the next set of experiments, I need some help in cleaning up the mess that I just made here. So could someone please come out and give me a hand in cleaning this up? Now, don't you wish you have helpers like that in your lab? My next experiment is with a series of beakers that have colorless liquids in them. And I'll bring this out here so everyone can see it well. I have 1, 2, 3, 4, 5, 6, 7, 8 beakers in the front row. In the back row, I have the same number of beakers, but they are a bit smaller. And what I'm going to do is mix the contents of the beakers in the back row with the ones that are in the front row, and we'll see what happens. All right, here we go. Maybe you can help out, but we'll see. Let's see if anything happens first. You know, nothing will happen unless we mix the chemicals together. So what should I do? Just stop talking and get on with the experiment, right? That's what I should do. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we get some help from the band too? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7.5, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How was that? Did you like this experiment? What we're going to do now is an experiment using carbon dioxide. Carbon dioxide is a gas at room temperature, and we all know about carbon dioxide because you know about carbonated beverages. They have a lot of carbon dioxide gas compressed in the liquid, and we need to think about carbon dioxide in lots of different ways. But right now, I wanted to think about carbon dioxide in the way that I have it here, because I have it in the form of chunks of dry ice. Dry ice is solid carbon dioxide. I use my gloves to pick up those chunks because the temperature of carbon dioxide in the solid form is minus 78 degrees Celsius. It's really, really cold, and I use the gloves to protect my hands from frostbite. Dry ice changes from being a solid to a gas directly without melting. When a solid changes to a gas without melting, we call that sublimation. Can you say sublimation? Sublimation is happening right now, but we can't see it. How come we can't see it? We can't see it because carbon dioxide gas is colorless. It's invisible. It also has no smell. It's odorless. And also, I tell you now, carbon dioxide gas is a greenhouse gas. And greenhouse gases have an effect on all of us. But let's do the experiment now with carbon dioxide. I ask you to focus your attention on what I have between my two hands. You see these cylindrical objects, and you see that they are arranged in pairs. Pairs according to the substance that's inside them. So this pair has what color? This one. This one. And what's in there are liquids. How can we tell they're liquids, not gels? Because from experience, we know what liquids do when we shake them up. And what I'm going to do now to help increase the visibility of the experiment, I'm going to put this white cover back here. Now, can you see the colors better now? I'm glad to hear you say that. So I'm going to reach for my bucket, and I'm going to take more dry ice and put the dry ice in the cylinders in a special way. And when I get done, you tell me what the special way is. Did I put the dry ice in every cylinder? I put the dry ice in every other cylinder. We leave one of the pairs for comparison purposes because a lot of things are happening right now, and the brain can't keep up with all the information that we get. But you see bubbles? Those are carbon dioxide bubbles. Where are they coming from? They're coming from the sublimation of the dry ice. How come we don't see them here? Because carbon dioxide gas is mixing with gas. Over here, carbon dioxide gas is mixing with a liquid. And we learned from this experiment lots of different things, including the fact that carbon dioxide gas does not dissolve very much in the water that I'm using here. In fact, if it were very soluble, we would not be able to see the bubbles. But a little bit of them, a little bit of carbon dioxide dissolves and causes these color changes in the acid-base indicators that we have used. And in all of these cases, the carbon dioxide makes the solutions more acidic. You've all heard of ocean acidification. That's when a carbon dioxide gas, the greenhouse gas, interacts with water in the ocean, in the lakes, everywhere else, and lowers the pH. You notice where the bubbles are coming up here, we form a mist, and this mist is condensed water vapor. So what I'm going to do now is use my gloves to protect my hands from heat, because I have a conical flask here that has in it boiling water. And those bubbles that you see here, they're not air bubbles, they're not carbon dioxide bubbles, they are water bubbles. And I pick this up carefully, and then I empty the water into the dishpan, and what do you see coming off the top? Steam is invisible. You can't see steam. I can't see steam. Nobody can see steam. What you're seeing is the condensation of water vapor. That's what it is. Look, when it's cold outside and you blow your breath on your hands to warm them up, don't tell me you see steam. You don't blow off steam that way. All right, so now I take the bucket with the dry ice that's in it, and I'm going to dump all the dry ice that I have in here. I'm still here. You notice that the fog gets formed, the condensed water vapor is moving downward, reminding us that carbon dioxide gas is heavier or denser than air. All right, so now I want to move over and do an experiment. And to do the next set of experiments, I need to clear this a little bit, and I need some chemicals from down here. Oops, I see I'm missing one chemical. Is there someone in the lab that can help me bring out the chemical I'm missing? Hello, Bucky. I'm very happy to see you here. Bucky, you are a very good student. Bucky is a very good student. Did you notice the eye protection he's wearing? He's wearing goggles. You notice that? And he also has a Science is Fun button here. So, Bucky, are you ready to help with the experiment right here? So you brought the ingredient I was missing. What we have is 3 beakers in front of us. This one has a clear and colorless liquid. This one has a clear and blue liquid. This one has a clear and green liquid. So why don't you take the ingredient that you brought in here and add some of it to the beaker that I'm pointing to right here, okay? You ready for this? All right. Whoa. Isn't that beautiful? Have you ever seen 2 clear and colorless liquids mixed together and producing such a beautiful yellow color before? Huh? You like this experiment? All right, Bucky, they like your experiment, so let's see what you can do next with this one. We have blue liquid in the front and a clear and colorless liquid in the back. And what you're going to do is add, yes, you have good technique, Bucky. A little more. And you succeeded in changing the blue color to green color. So that's a very, very good way of doing an experiment. Bucky, we have one more to go here. You ready for this one? A clear and colorless liquid, and we have a green liquid, 1 shade of green in the front. So add that. Just add a little bit. Let's see what happens. Ooh. You get 2 colors. You have red floating on top of the green. So that's a very, very good mixing of different chemicals. Very colorful, Bucky, just like you are. But Bucky, I know that you are a studious student and you do well, no, I know you do well. How long is it going to take you to graduate? What? Let me see this. 1, 2, 3, 4. I have 5. Well, we are different after all. But I'm so glad you're going to graduate in 4 years. That's what everyone should try to do, graduate in 4 years so that you move on with adventures that are meaningful in your life. And Bucky, in order to graduate, you have to do well on exams. I know final exams are coming up here, so I know you have to go on study. So thank you so much for coming by, Bucky, and doing all these wonderful experiments. Thank you, Bucky. Thank you very much. I have another experiment that I'm going to do with, what is this? What does this look like? Yeah, what color is it? Hey, do I have to ask all the questions all the time? I know you're thinking them, but we all have to develop the skills of sharing what we're at. So here's this nice blue racquetball. It's pretty bouncy, as you would expect it to be, because we know from experience what these balls do. So what I'm going to do is put this rubber ball in the liquid nitrogen like this. I'm going to move it over here. And I need more liquid nitrogen. Do I have any more liquid nitrogen? Yeah, I have liquid nitrogen. How much do I have in here? I don't know. We're going to find out. There it is. And you see it's boiling. The liquid is boiling. Why is the liquid boiling? Because the ball is warmer than minus 196 degrees Celsius. So what I want to do is cool this off. Stay down there. Stay down there. Another interesting thing about the ball, it floats in liquid nitrogen. So that's something else to think about. How come it doesn't sink in there? It floats in there, so stay in there. Because what I want to do next is fill up my big doer with more liquid nitrogen. Here we go. What is this white stuff that's coming off the side? You're thinking about that, right? You're wondering what it is, right? You know what it is. It's cold nitrogen gas and hitting the environment where there is moisture in the environment. So a little bit of condensed water vapor. So more over here. All right. So let that cook a little more. A little more. Why is it boiling now? Because the tongs are metallic and they're warmer than minus 196 degrees Celsius. So I've got this balloon in here, and you can tell it has a gas in it lighter than air. You're covering your ears again? Maybe you need to do that, maybe you don't. So let me show you what happens when I take liquid nitrogen and I put it on top of the balloon here to cool off the gas that's inside. Sounds like the balloon is hurting. And then we wait for it to warm up. As it warms up, the gas atoms, the helium atoms that are in there, are going to move faster, and then there's the balloon going up, 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 up. All right, well, there's one other item that I would like to work with you, and that is to reach back here and get one of those very pretty chrysanthemums. Isn't that pretty? Beautiful color. Where are you going? What I'm going to do is take this very beautiful flower and put it in liquid nitrogen. And add more liquid nitrogen. What do you think is going to happen? Anything? It's going to get cold. I know it's going to get cold, really cold, but what else? You think it'll stay pretty? Let's find out. It still looks pretty, right? But something has happened to it. It has become very fragile. Very fragile. So, all right. Now I go back to the rubber ball, and a rubber ball is still there. I think I should put my gloves on, right, to protect my hands from frostbite, because what I'm going to do is use the tongs to get the rubber ball out. So come on out. Hello? Come on out. There it is. I've got it. And I'm going to walk over here, and let's see now how bouncy this ball is. You ready for this? Here we go. That was a shattering experience, wasn't it?
Is this the right way?
Well, I'm not sure.
Where are we?
I think we should explore a bit more.
Oh, look what's up ahead.
Oh, well, I know where we are now.
Where?
Oh, this is the lab of Professor Shakashiri.
Well, there are many wonderful things here.
Hello.
Dorothy.
This is my friend Tin Man.
Hello. Welcome back, Dorothy.
I'm so glad to be back.
I'm very happy to see you. You know, in my lab, we like to do experiments. Would you like to do some experiments?
Oh, of course. And I think I see some things I'd like to use. Oh, how about that one?
All right.
That cylinder, does that have water in it?
Yes, that's water in the cylinder.
All right. Well, first I need to wear my safety glasses.
Ah, you remember, obeying the safety rules.
This is milk of magnesia, right?
Yeah, that is milk of magnesia, yes. What are you going to do with it?
I'm gonna add it to the water. Ooh, I like that.
Yeah.
But I like things that are more colorful. This says universal indicator. I'm gonna add that as well.
Dorothy, you know a lot about chemistry.
Well, you haven't seen anything yet. This is vinegar, and when I add it, just watch what happens.
Oh. Wow, that sort of looks like a rainbow.
Oh, it does. You know, that reminds me of one of my favorite songs. Somewhere over the rainbow, way up high, there's a land that I heard of once in a lullaby. Somewhere over the rainbow, skies are blue, and the dreams that you dare to dream really do come true. Someday I'll wish upon a star and wake up where the clouds are far behind me, where troubles melt like lemon drops away above the chimney tops. That's where you'll find me. Somewhere over the rainbow, bluebirds fly. Birds fly over the rainbow. Why then, oh why can't I? If happy little bluebirds fly beyond the rainbow, why, oh, why can't I?
Thank you, Dorothy. That was really, really beautiful.
Well, thank
Such
you.
great talent right here.
Thank you. Oh, but the rainbow's gone now. Well, let me see if I can bring it back. Oh, there we go.
Well, that's beautiful, Dorothy. You know, I think I could use some help with some chemicals, too.
What do you need?
Well, my arms are feeling a bit creaky, and I could use some oil.
You would like some oil?
Yeah, but my can is empty.
Oh, well, let's see if I can help you. Actually, I think I can help you. I have a lot of oil in here, but watch this experiment first.
Okay.
I have this glass container and a smaller glass container. I put it in here, and what I'm going to do is fill the small container with oil. So you ready for this?
Yeah,
Here
I'm
we
ready.
go. We pour it in like so, like so, and now it's overflowing.
Well, that seems
It's
like a lot of oil.
It is a lot of oil, yes, yes. And what else do you see?
Well, the beaker, it's disappearing.
The beaker is disappearing. The beaker is still there.
But where'd it go?
I'll show you. I'll fish it out. It's right here. So, you always have to think about what's going on, what is happening in the experiment. But you said you needed some oil, so I've got some oil for you here. I hope this helps.
It sure will, thank you. And you know what? I was also kind of in search of a heart.
Oh, well, I think I can help you with that.
You sure know a lot about working in a laboratory, Dorothy.
Well, especially in such a well-equipped lab as this. Well, see that paper over there?
Yeah, this one.
Is that piece of paper like the one I saw you use
Yes,
before?
it is.
Well, watch as I spray this onto that paper.
Oh, well, it's a heart.
It is. There you go.
Thank you, Dorothy.
How wonderful. You're happy now?
Oh, I sure am.
Well, would you like to do some more experiments?
Oh, I would, but I think we need to get going. Thank you so much, and we will be back.
Thank you for saying that, and thank you for coming, Dorothy and Tin Man. Have a
you.
safe journey.
Well,
Thanks,
thank you.
Professor.
Thank you very much. And now I move over here and try to do another experiment. This experiment is going to be done in a very special glass assembly. This is a glass spiral attached to a funnel on top. And what I'm going to do is mix different liquids with it. Actually, two different liquids. One is clear and colorless, and the other one is clear and blue. And the way I will do this is first I will take the stoppers off, and then I will mix the liquids by pouring them down the funnel in the dark, please. So if we turn the lights down, there we go. This is the release of energy in the form of light. There's no heat involved here. This is still at room temperature. Let's have a quick look at this in slow motion, and then you see the nice blue emission of this mixture spiraling down. Isn't that beautiful? Thank you, Ben. Thank you for that. Hello, Santa.
Happy holidays!
Oh.
Happy 50th anniversary!
Yes, 50 years, yes. Wonderful. I'm so happy to see you, Santa. Did you get my list?
Oh, a very, very long list, yes.
It wasn't all that long. I've been good. Haven't I been good? Did I get anything, Santa?
Has he been good? Have you been good? Oh, let's see what a good boy gets. Are you ready?
I'm ready.
Oh,
I'm ready.
Oh,
Oh, my goodness. Oh, my goodness. Look at this. Can you see what this pillow says on it? It is the International Year of the Periodic Table. The periodic table was proposed 150 years ago. And the periodic table has in it, of course, element number 50, right?
50.
Which is the element for this year's program, and the element is tin. Tin is the element here. So, oh, it's on both sides too. Let me show you this. Thank you, Santa. That's really, really cool. I appreciate that. Thank you.
My pleasure.
Did I get anything else?
Oh, in this year of tin, of course.
A box.
A box.
Shall I open it now? Shall I open it now? Yeah. All right. Let me open it now and see what the elves have prepared. Ooh, ooh, ooh. That was really on my list. This is 2 tin soldiers. They're made of tin. And the elves in your workshop are very, very good at what they do. They're very skilled. Do they learn from you, or do you learn from them?
Oh, we learn from each other.
You learn from each other. And how is the weather up there? Is the North Pole affected by global warming?
We have some very skittish polar bears these days.
Well, we all have to pay attention to that very important challenge that we all have. So, Santa, thank you so much for this. Was there something else that I got?
Oh, yes.
Oh, okay. Open this.
Please.
All right, I open it, and I pull something out. Ah, it's a tinsel.
Tinsel.
A tinsel, you get it? It's a tinsel. Thank you, Santa. It's very thoughtful of you and of the elves. And Santa, would you like to do an experiment with me?
Oh, would I?
All right, well then come around the other way, right?
Oh.
And you know, Santa, in my lab, we always obey the safety rules. So guess what I have for you here?
Goggles!
Yes, you knew that, right? You knew that. And
Of course.
Santa, what we're going to do, you and I, we're going to do an experiment by taking the clear and colorless liquids that are in these 2 round bottom flasks and emptying them into there, but they're hot. So we put our gloves on. Will you put your gloves on, please?
Gloves.
So that we don't burn our skin. And so the first thing we do after putting the gloves on is to take the rubber stopper off, just like I did. You do it over there, I do it over here. And we lift up. Okay, and then you just empty it in here. Just glug, glug, glug. Go ahead.
Oh.
And you see the condensed water vapor coming up the top, right? Okay, so then we quickly go back here, and we take the bigger flask, and we put that in here, like so, without spilling it. And then we take the smaller flask, take the rubber stopper off, and put that in there, like so. And then we take the big rubber stopper, put it on, and we have to mix the chemicals together. And I can see changes already. I can see changes. Can you see changes in what you're doing?
Oh, yes.
I see the liquids are getting darker.
I can see your face.
You can see my face. I can see your face too.
Lucky you.
And the black color is changing. Yes, I'm very lucky that you're here, Santa. And now, Santa, you see what you and I have done. We have made holiday ornaments by depositing a thin film of silver at the bottom of each one of those flasks. So
Fantastic.
we can put them here. And if you would like to join me in holding one up and lift them up like this, you like this experiment? Well, Santa, I know you have so many stops to make. I don't want to keep you here. Thank you so much for joining me today and giving me a great, great pleasure. Thank you so much.
Thank you for all you teach us, Professor.
Thank you so much. Happy holidays to you. Thank you.
Happy holidays to you. Happy holidays. Happy holidays.
My next experiment will be done here, and I'm going to ask Professor Leckrone to join me.
Certainly.
Are you willing?
I'm happy to do it.
So,
But
Mike?
first, Professor,
Yeah?
safety goggles.
Safety, of course, safety. Put your safety goggles on. And what I have this liquid here. I'm going to turn this liquid blue. So what I'm going to do is I'm going to add it here And I want the liquid to be blue.
Well, it's not blue now.
Well,
It's not blue.
be patient. Let me try this one here. Does that help? The blue? I have to mix things together. The blue?
I don't see any blue yet.
No blue yet? Okay, well, I'll tell you what, I have a battery right here. I'm going to put the battery in there.
You should put a battery in there.
Why not? Yeah, in this day and age, we use a lot of battery-operated things, right? So we're going to put the battery in there, and we're going to mix. What do you say now, Mike?
It turned blue.
It turned blue. The liquid is blue. Yeah. So this is a battery-operated chemical reaction. But we should recover the battery.
Yes. Let's get the battery out of
We
it.
should recover the battery. So let me do that by pouring this blue liquid into this beaker here.
But it turned clear again.
Well, you just be patient. The blue is there. It's hiding. You can't see it.
We'll get the battery too.
Oh, but yeah, pick up the battery. Pick up the battery. Okay. Yeah, it's there. And now, what's your favorite color, Mike?
Well, that's nice. The blue is nice, but I prefer red.
You have anything red on you other than a very nice outfit?
What do you think? I've always carry a red handkerchief wherever I go.
Thank you. So may I borrow it from you?
Absolutely.
Okay. So the blue is there. It's hiding. I'm going to show you. I take your red. Yes, I'm going to put it here.
It looks clear to me. It turned blue.
There's the blue. Yeah. But what's your favorite color?
Well, I like red a whole lot better than I like blue.
You like the red?
I like red all the time.
You like the red. Okay, so let's see what we can do.
You're amazing. It turned red again. That's absolutely amazing.
Do you like this experiment?
Oh, science is
Do
crazy.
you like this experiment? But you know what? The blue is still there. I'll show you. I'll just take this cloth that you gave me, the red one.
The red
we'll
one?
We'll keep it red. I'll rinse the blue out right there. Isn't science wonderful,
It's
Mike?
absolutely wonderful. And I still love the red handkerchief.
Thank you so much, Mike, for helping with this experiment. Thank you. Thank you so much. Now I would like you to welcome my longtime friend and collaborator, Dr. Rodney Schreiner. Rod? Hello, Rodney.
Hello, Bassam.
Always happy to see you.
And I'm happy to be here on this special 50th anniversary.
Thank you, Rodney. Rodney and I have known each other for 49 of these 50 special presentations. Thank you, Rodney. Thank you. Yes, he deserves
It's a great pleasure
yes.
to be here. Oh, and you notice I brought you something in honor of the 50th anniversary.
Yes.
It's a token.
And it says 50
and
on
it says 50.
Yes, but element 50 is tin.
It's tin,
This
right.
doesn't look like tin.
That's not tin, that's copper. I was going to make you a tin one, but I learned something about tin, and that is tin is very soft, and it would be hard to make one that's sturdy.
Copper is pretty hard here.
Yeah, copper is very sturdy.
Yeah. Is there something you can do with that copper?
I think I can make it look like tin.
Ooh.
How's that?
Yeah.
Well,
Let's see
try
that.
it out. Let's try it out. So I am going to, well, let's see. We are going to need some heat. And I am going to put some gray granules in the bottom of this dish. There we go. Spread them out a bit. And then I'm going to take the 50 and put it on top of those granules.
What is this gray material?
This is zinc,
The element zinc.
the element zinc.
Metallic zinc.
Metallic zinc ground up into a fine powder. Well, let's see. Now I'm going to add some of this liquid and cover it all up with liquid.
What's this liquid?
This liquid is a solution of zinc chloride.
So zinc chloride dissolved in water.
So I'm going to set them up here, and then we're going to light a burner.
All right. I can help with that.
Yes, turn on the gas.
Ready?
Yes.
Okay.
There it is.
More?
No, that's good.
That's good?
Right.
Okay.
And so I'm going to put the burner there. And it's going to have to cook a little while. And while it's cooking, I'd like to show you a few things about the element of the year, about tin.
Yes, please.
So what I need to do is to get some things from back here. Now, I told you that tin is a soft metal, and here is a bar of tin. And to show you that it is indeed quite soft, I'm going to bend it. And it's very easy to bend. Very, very easy to bend. Oh, and I can hear something happening, too.
When you bend it?
When I bend it.
I can barely hear it. Oh, yes, I hear it now.
Yeah?
Yeah.
Yeah, you have it.
Yeah.
Maybe if I bend more than one at a time. Here I have 3 of them. Here,
Oh, yeah. I can hear that.
yes, that sound that we hear, that's called the tin cry.
Oh. Is the tin sad?
Well, it sounds that way, but all that's happening is that tin has very big crystals inside, and when I bend it, those crystals break. And so we're hearing the crystals of tin breaking as I bend it.
I see.
Now, because tin is a very soft metal, it can be formed into a very thin sheet, like most soft metals can, like aluminum can. And a long time ago, tin used to be formed into a foil, just like aluminum foil. So
This is tin?
This is made of tin. This is
This
pure
is tin foil?
Pure tin metal, pure tin foil. Now, this has been replaced now in our everyday lives by aluminum foil. But some people still call tin foil, they call aluminum foil tin foil.
I remember that when I was a little kid.
Yes.
Just a long
yes.
time ago.
And I know some people who still call
They still call it tin foil.
still call it tin foil. Now, most tin today isn't used as pure tin. It's mixed with other metals to form alloys. And one of the oldest of the alloys of tin, it's a mixture, mostly copper, with some tin, and it's used to form bronze. About 5,000 years ago, our ancestors discovered how to make bronze.
By mixing copper with a little bit of tin?
With a little bit of tin. It's mostly copper. But it's very sturdy, and it's now used to make statues and plaques like this one. And now there's another alloy, also an old one, of tin, which is pewter. And here's a pewter goblet.
What's that made of?
It's also tin and copper, but in this case, it's mostly tin with a little bit of copper.
It's just the opposite of the bronze.
Just the opposite of bronze. Now, it can be polished to look like silver. So sometimes you see pewter which looks like silver. This one doesn't, of course. But the most common use of tin is in making solder. Solder melts at a very low temperature, and it's used to attach 2 metal pieces together. So plumbers use it by melting it to join copper tubing together or copper pipes together. And people in the electronics industry use it to join pieces of metal together to make conductive materials. Now, let's see what's happening over here.
All right.
This is
I see the liquid is boiling.
It is boiling, yes.
And there's some color changes on the 50, on the token that you gave me.
Yes.
Yeah?
Yes. Okay.
There's kind of a metallic,
Yeah,
silvery metallic color to it.
Okay, let me rinse it off. And now it's wet, so I'm going to dry it. Dry it. And now?
Most of it has changed color.
Now it's silvery.
So what happened here when you cooked it in the mixture?
While it was in here, it was being plated with tins, with zinc rather. There's zinc metal and zinc chloride in there, so it coats the copper with zinc.
I
and
see.
that makes it look sort of like tin, but of course it isn't tin, it's zinc. But this is the 50th anniversary, and what metal do people usually associate with the 50th anniversary?
Gold.
Gold, right. So let's see if I can make this look like tin. I will move this away. And we can turn this up a little bit so it gets hotter. Yes. And now I'm going to heat. Heat it.
Heat it some more?
Yeah, more gas, please. There we go. We want to get it nice and hot.
So there's a thin layer on top of most of the copper.
Yes.
Oh, oh,
And it looks like
I
it's
can see
changing
changes,
color.
yeah.
It's changing color.
yeah.
And again, what I want to do is cool it off because I want to handle it. So I'll
Yeah.
put it in here.
Whoa.
It was hot.
You still need the flame?
No, we're done heating. We're done heating. And of course it's wet, I'll dry it off. And so, in honor of your golden anniversary, we now have a golden 50.
Thank you so much, Rodney. Thank you, thank you. Thank you, Rodney Schreiner. Thank you very much. My next experiment is with plastic bottles. I have 3 plastic bottles of different sizes. There's one, there's another one, and here's the third one. And of course, you see that I have a fourth one. But the fourth one shows the inside of how these screws are put in. They are not touching on the inside. So this cutaway is to show you that they're not touching. And each bottle has a small amount of a clear and colorless liquid in it, but also each bottle has a cork on top. Let me show you what I'm going to do here. I'm going to take this source of a spark. It's called a Tesla coil. I'm going to hold this metallic spatula very, very tight and push the button, and now you can see a spark. There you can see the spark, right? Now I'm going to touch this screw and show you the spark is jumping across the gap that separates the 2 screws. All right. In the first bottle that I have over here, I'm going to touch one screw and see what happens. You ready for this? You sure you're ready? Here we go. Are you ready? Are you ready for the next one? Here we go. And how about this one? You ready for this one? Here we go. You ready? 1, 2. I'm glad you like that experiment. I like that experiment too. You have been a wonderful audience on this very special 50th anniversary program. I want to thank you for coming here. I want to thank you for your support of our program. And I, of course, want to thank everyone who's made it possible, and especially thanking you for the eruption of your enthusiasm and the outburst of your affection. And thank you for all your support here in this very special program. Thank you all very much. Thank you. Thank you. Each one of us, we all have awesome responsibilities, not only to ourselves, but to the future generation that we love so much, to protect our planet and try to mitigate climate change. And there's my daughter and my granddaughter. Thank you, Violet, and thank you, Elizabeth.